on, what happened is I'm not supposed to restart the meeting. I'm supposed to join the meeting because the meeting is already going on. So probably when I crashed, it just made one of you guys the host, right? For a second. So
Daniel's host, I think.
yeah. So basically what I'm supposed to do is I have to get the meeting ID number and join. Oh, no, crash. So how many of you got booted? Crash. Oh, a few of you. Okay.
Me.
Yeah, me too. But my iPad reconnected back, but my computer did not. So that's why I threw in the chat. Don't worry, hang on, I'll be back. Did you see my chat? Okay, now we're up to 29. Well, I'm 2 of them, so we're almost all there. So so this problem, you're going to end up using the squeeze theorem. So what ends up happening is, yeah, it's okay, Cassandra. We're all got booted right now for the Zoom meeting. So you haven't missed anything. So we're going to use the squeeze theorem. The negative e to the minus 2x, limit as x goes to infinity. That's going to be limit as x goes to infinity. I'm going to rewrite it with a positive exponent. So as x goes to infinity, this whole term on the bottom is going to get really, really large. So negative 1 over a number that's really, really large is going to go to 0. Now we're going to do the limit as x goes to infinity of e to the minus 2x. So if I were to rewrite this as limit as x goes to infinity of 1 over e to the 2x. So as x gets really, really large, that whole denominator is going to go to infinity. So 1 over a number that's going to infinity goes to 0. So now by the squeeze theorem, you would say, since this is always in between these two guys, and those two guys are going to 0, by the squeeze theorem, that the answer to this problem is going to be going to 0. I'm not going to write it all out, but that's basically what happens. Does that make sense?
Why did you put the e as a denominator when why did you put it over a -1?
Because it's a negative 2x. So when it's rules of exponents, if you drop it to the denominator, it becomes a positive exponent. So it's easier to see that it's going to go to infinity. So 1 over infinity is 0.
Got it.
All right, I forgot all the other questions because it's a new chat. All right, yeah, no problem. So Brian, no problem. Number 27.
Can you do 23 after, please?
Okay. Limit as x goes to infinity of the square root of 9x squared plus x minus 3x. Ooh. No, what? This is not even a fraction. So what I'm going to do here is I want to multiply top and bottom by the conjugate. You're saying there is no bottom though. Well, I'll make it. Let me see here. I'm not talking because this one caught me off guard here. So the top, because it's an a minus b, a plus b situation, 9x squared plus x, and then minus 9x squared. Okay, that would work. And then the bottom is just itself. The 9x squareds cancel out. Limit as x goes to infinity. Give me 1 second here. Okay. So let's divide top and bottom by x. Hmm. I divide this whole thing by x, but it's a square root on part of it. Wait a minute.
Aren't we supposed to divide everything by x squared?
Or root x squared, maybe?
Yeah, root,
Yeah,
root
but
x squared.
yeah, but then the 3x.
Three x would be left as 3 over x, right? That could be zeroed out.
Oh, hold on. I can't just divide this guy by square root of x squared, but then this one by x. You can't do that because you can't just divide each one individually. It's got to be the whole thing.
I cheated,
Let
I
me
think.
let me think about this, and I'll come back to you on this one after the break. What was the other one you wanted to do? Number 23?
Yeah, if you don't mind.
Yeah, this one is easier. All right, so I'm just going to multiply top and bottom by x cubed. So let me rewrite this. Limit as x goes to infinity of square root of 1 plus 4x to the 6th over 2 minus x cubed. So I'm going to divide this guy by x cubed, which I'm going to write it in the form of square root of x to the 6th, and this whole bottom by, oh yeah, you know what? I could just divide everything there, but I just split it. Yeah, I'll come back to that later. Let's just do this. So I'm going to divide the bottom by x to the 3rd, which is the same as square root of x to the 6th, because we're talking about large x values. So this will be equal to limit as x approaches infinity. So you got, put this whole thing on the top. That would be 1 over x to the 6th plus 4x to the 6th over x to the 6th. The bottom will be 2 over x cubed minus x cubed over x cubed. What number was this? 23? So
Yeah,
then, so we got limit as x goes to infinity of 1 over x to the 6th plus 4 over 2x cubed minus 1. All right, now if we take the limit as x goes to infinity, this goes to 0, right? That goes to 0. So we got square root of 4 over negative 1, which would be 2 over negative 1, which would be negative 2. Does that make sense?
yeah, it does. I did it a little differently. I just factored from the very beginning. That's why I was confused. But
Well, you
yeah,
can't factor it.
well, I took out the x to the 6 and then
You can't
parentheses
because
1.
it's 1 plus 4x to the 6th. If it was just 4x to the 6th by itself inside a radical, if it was that, you can take out the x to the 6th, but you can't take out the x to the 6th when it's 1 plus 2 different terms.
Okay, all right, that's okay. That's right. That's why I was sick. All right, thank you.
All right, I think I got this lot. Now I was thinking about this one still. Um,
Professor?
hold on 1 second. Are you finding the last problem?
Yeah, 23.
Yeah.
So on x to the sixth, is it okay if you take it out, but you take it out still within the radical?
No, you can't take out the x to the 6 because it's 1 plus 4x to the 6.
1. So you can't just take out x to the sixth inside the radical?
No, if it was 4x to the 6, if this was the situation, then you can take out the x to the 6 and call it x cubed square root of 4. Or actually 2x to the third. But because it's 4x to the 6 plus 1 all inside the same radical, you can't take it out.
Yeah, so you can't take it out within the radical as well? So you can just put the x out as x to the 6, parentheses 4 plus 1 over x over 6 and have that all in the radical?
You have to write it out because I'm not sure what you're saying.
I don't know how I
But-
can give you.
Because you see, take it out, but have it be inside the radical. Well, then you're not taking it out.
Or I mean, like, I don't know, just take it out so you can distribute it back in.
You mean like
What step-
factor
wh-
within?
What
Yeah,
step
yeah.
are you talking about? Are you talking about this line or this line?
The second line, I think.
This line?
Yeah.
Well, we're just do the problem this way. I'm going to come back to this one. I got to do this one. This is really frustrating me here. 1 second. Don't talk to me.
All right.
All right. So I'm going to do this here. Square root of x squared. So the top will be 1. The bottom. All right. I think I got it. So you got, I don't have right time. I mean, I don't have room to write the limit as x goes to infinity. Just keep that in mind. This will be 9 plus 1 over x, because the x squared over x squared cancels out. Plus 3, take the limit as x goes to infinity, you get that 1. So you get 1/6. All right. Is the answer 1/6?
Yeah.
All right, so let me write it out cleanly for you. All right, so you were okay up to this step right here, right? Okay. So let me write it out again.
So that was possible because the square root of, or the rooted x cube is the same as just x, right?
Yeah. So let me show you how to do this one. So we got up to this step. I multiplied top and bottom by the conjugate here. Then I did that and I got to here. So I'm going to divide top and bottom by x, but the way I'm going to write the x is x here, and the bottom I'm going to divide by x. But yeah, I'm going to divide the whole thing by x, which when I distribute it to each one, this is going to be square root of x squared, but this one I'll just keep it as x. So what I did is I'm dividing the whole thing by x, but then once I distribute it on the next step, it's going to look like that. So then what ends up happening is you're going to get limit as x approaches infinity of 1 over. So then what I'm going to do here is x squared, you're going to square root of x squared, you're going to put underneath each one. So you're going to get square root of 9x squared over x squared plus x over x squared. And then plus, this is just going to be 3. So then you got the limit as x goes to infinity of 1 over 9 plus 1 over x plus 3. Now we can take the limit as x goes to infinity. So once we take the limit as x goes to infinity, this goes to 0. So you get 1 over the square root of 9 plus 3, which would be 1 over 3 plus 3, which is 1 over 6. So go ahead and write this down, and I'm gonna get back to you here in a second. Let me just ignore the insignificant numbers. This is not chemistry class. Insignificant numbers. Watch your language.
Like for 23, when you're dealing with infinity, like the +1 isn't gonna matter, right? Even if it's in the radical.
No, you can't just ignore. Well, this okay, you guys. I'm trying to still do that. Remember, Herday, I don't know what you were saying about just take out the x to the 6, but keep it inside the radical. That makes no sense to me. You write it out for me, scan it, and then email it to me, and then I'll take a look at it, okay? And I'll tell you what you can and can't do.
Could I send it in the Zoom chat?
Huh?
Could I send it in the Zoom chat?
Well, no, we got to move on. We got a lot to do today. I'm going to move on. I don't want to talk about this anymore. Let's see. Is there another question here? So sorry, Professor. I just got to the Starbucks.
The Wi-Fi was down at my place. I went to my parents' place. Their Wi-Fi went down, so now I'm at Starbucks.
Okay. By the way, I like Starbucks, but I have lost faith in humanity because there's a Starbucks by my house. On a hot day, not right now, but on a hot day, I see line of car wrapped around the building all the way out. People waiting in their car for 20 to 30 minutes for a cup of Starbucks.
Try having in and out in the same parking lot.
I go like, you know, I can understand you waiting for lunch because lunch is a necessity, but a cup of Starbucks is not a necessity. Just go to the donut shop and get a coffee. Go to somewhere else, get a coffee. Get instant coffee at your house or something. When you have to have your car running for half an hour on a drive-through so you can get a Starbucks, there's something wrong with society. Madison, do you agree? Madison says, I'm one of those people. All right, we got to move on. Sorry, to 2.7. We're going to start that.
Yeah, strong feelings on Starbucks.
I like Starbucks, but drive-through, I'm not a big fan of. I mean, the whole concept of Starbucks is somewhere you kick back, relax, and you're paying $5 for an overpriced drink. If you're just going to go drive-through, just hand them your $5 for a coffee cup that costs less than 50 cents to make, then there's a problem with that. All right, moving on. Derivatives and rate of change. So let's talk about in algebra class, when you graphed a line and you said, all right, the slope of this line is 2/3. It made sense to talk about the slope of a line, the rise over the run, when you had a straight line. But if you had a curve, it didn't make sense to say what's the slope. But you still want to know, like, all right, is this line increasing or decreasing? So even though I can't ask you to find the slope of a curve, what I could do is say, well, can you find the slope of the tangent line at a particular point? So like, let's say this line right here, can I say the line that's tangent to the point at that, so the tangent to the curve at that point, can you find the slope of that line? So here's how you do it. Let's say we call that x value x. Now, I don't know how to get the slope of that red line, but if I would say, if I go out a little bit and say, you know what, this red point right here, And I don't know how to get the slope of that red line, but I can connect these 2 points and say, all right, that blue line segment, I can get the slope of that because I got 2 values. So what I'll do is we'll call this x value x plus h, which makes the distance from here to here h. So what is the first point? It's x comma f of x. What's the second point? It's x plus h comma f of x plus h. Now, how do I find the slope of the line of this blue line? Let's find the slope of this blue line. Well, remember from algebra, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to go f of x plus h minus f of x all over x plus h minus x. So you got x, y, and then you got an x, y. So you got to go y sub 2 minus y sub 1, and then x sub 2 minus x sub 1. Now, these x's cancel out. So we're left with f of x plus h minus f of x all over h. But that gives me the slope of the blue line. I originally wanted the slope of the red line. So I would say, all right, well, they're not quite the same line. What if I made h a little bit smaller and brought in this point more? So as you see this point that's right here, I brought it in more, so h became smaller. Now it's this distance from here to here. So now my new line is going to be from here to here. So notice if you zoom in here, I guess then I can zoom in. See this as I zoom in? See the 2 blue lines that I drew? It's from here, now it's here. Well, what if I make h even smaller and I bring in the point even more? Now I got this point all the way to here. You see how as I get closer and closer, this is a really nice feature. As h gets smaller and smaller, this blue line keeps getting closer and closer to what the red line looks like. You see that? So if I were to take the limit as h goes to 0, the blue line will become the red line, and that will give me the slope of the red line, since the blue line will become the red line when the h goes to 0. That means the distance of the 2 points goes to 0. And this right here, we call it the derivative. So f, there's a little apostrophe, it looks like a 1 of x, so that means the derivative of f of x. F little apostrophe x, or sometimes we call it f prime of x. So that is the limit definition of the derivative right here, what I boxed. So after all that, if this was an in-class, if we were meeting in class, I would say you'd have to memorize that. So f prime of x equals the limit as h goes to 0 of that. So this is the limit definition of the derivative. Oh, I forgot to put a little parentheses there. F of x plus limit definition of the So are you guys having a, did you guys have a meeting today with tutoring with Aaliyah? Or was it Tuesday?
Yes.
Today.
Yeah, she said she couldn't make it to class today because you guys stressed her out and she has to go drinking.
Starbucks, right?
No, I'm just joking. Yeah, Starbucks, yes. All right, so let's do an example. So I'm going to ask you to find the derivative of f of x equals x squared. So this formula that I boxed, I would recommend that you write it on another sheet of paper and have it right next to you. So as we do problems throughout today's class, it's always right next to you, so you don't have to keep flipping back to your previous page. So if you remember the first week of class, we did some work with difference quotient, and I'll say you'll see in a couple of weeks why we keep doing these. Now you'll see. So if I say find the derivative of f of x equals x squared, you're going to have to use that formula in the box. Well, before I use that formula, well, so what I wrote in black would be provided for you. Anything that I do in blue, you should be able to know how to do. Well, f of 5, you plug in 5. F of 6, you plug in 6. F of x plus h, you plug in x plus h. X plus h squared. So so now let's go to the formula. What is the derivative? It's equal to the limit as h goes to 0 of f of x plus h, which is x plus h squared, minus f of x, which is the question given to us, over h. So that is my f of x plus h minus my f of x all over h. So then once you get to here, it's very similar to what you did in the first week, except now you have the limit as h goes to 0. You can't take the limit as h goes to 0 yet, because if you plug it in, you get 0 over 0. So we're going to simplify this, use some algebra, and then hopefully afterwards you can plug in 0 and get an answer. Yes, I just said, looks like it is the difference quotient. It's limit as h goes to 0 of the difference quotient. So x plus h whole thing squared, that's just x plus h times x plus h, which is x squared plus 2xh plus h squared minus x squared all over h. So the x squareds cancel out, and of the two terms left, I can factor out an h. H's cancel out. You get limit as h goes to 0 of 2x plus h. All right, so now we can go ahead and plug in 0 for h, 2x plus 0, so the answer is 2x. So after all that work, the derivative is equal to 2x. So if f of x equals x squared, right here, the answer is 2x. Now, what good does that do us? Well, for right now, for this section, it helps you find the slope of the tangent line. So I picked x squared, an easy example at first, because I can show you exactly on the, how many of you are still looking at this? Because I want to scroll. Damaris, that's a fancy Starbucks. There's a nice view. What's in the background? You know, at the upper second floor or what?
No, I'm on the ground level. I think that's an auto zones behind me.
Oh, never mind. It's a small screen. I didn't see.
I can show you. Can I say hi? My
Oh,
sister
okay.
wants to say hi.
Oh, hello. It must be very tough to be sisters with Damaris.
No, I love her.
Oh, okay.
You tried.
Hey, I love my brother too, but it's hard to be brothers with him. He's very demanding.
Tell them.
Hey, is that the Starbucks in Anaheim?
No, it's the one on Whittier and Beach.
Oh no, okay. I thought the view would kind of look like it. Never
Palm,
mind.
I don't see palm trees. Never mind.
I had a bad experience at Starbucks, which we won't talk about. All right, not with the Starbucks people, but another customer. Moving on. uh, okay, so oh my God, Daniel, are you trying to get me going again?
Just a little.
What grade is your sister in, Damaris?
I don't even. Eighth grade.
8th grade. Okay.
Yeah.
So I'll see you in my calculus class in a few years.
Yeah.
Hmm.
She's smart. She'll make it.
Okay. So there's the parabola, f of x equals x squared. Now, we found out that the derivative is equal to 2x. That's what we did up here. Now, if I asked you what's f of -2, that's -2 squared, which is 4. That gives you the y value. At -2, the y value is 4. But if you were to plug in -2 into the derivative, which is -4, that gives you the slope of the tangent line. So what we just did, -4 is the slope of the tangent line at x equals -2. Now, if someone says, you know what, I actually want to know the slope of the tangent line at x equals -1. I'll say, all right, no problem. F prime of -1 equals 2 times -1, which is -2, which is right here. So you see how the slope of any line tangent to the curve at any point, I can get by just plugging the x value of that point. So going back to this, so you see this problem. Whenever you're looking at a graph, look at it left to right. So always think left to right. So imagine you're on a roller coaster. Here, you're dropping down at a really fast rate. Then here, you're dropping down really fast. Here, you're at 0. Then you're going back up. So as you're going up a little bit, more. Now it's getting really steep, really steep. So as x gets larger and larger, the slope of the tangent line gets larger and larger here too. But every graph is different. So just remember, when you plug in an x value into the derivative, that tells you the slope of the tangent line. And of course, if the slope of the tangent line is positive, that means that it's increasing. If the slope of the tangent line is negative, it's decreasing. So that's one of the things slopes derivatives are used for. Is this making sense? So right now, what we're going to focus on is this process right here that I did in blue. If I give you a function, use the limit as h goes to 0 of the difference quotient to get your derivative. Now, I'll go ahead and answer the question that some of you are thinking. They're all like, you know, I know a much easier way to do this. Well, yes, I know that easier way too. But today, we're going to do it this way. And you have to know how to do it this way for the quiz next week and the test. So let's practice this. So let's move along to the next question here. What if I asked you to take the derivative of f of x equals x squared minus 5x? So again, hopefully you have the formula written right next to you, so I don't have to keep scrolling up. This formula right here that I boxed, you have that. So you see how you need to know what f of x plus h is. So let's figure that out first right at the beginning before we do anything. F of x plus h is you plug in an x plus h wherever you see an x. So now the formula is the derivative is equal to limit as h goes to 0, don't forget that, of f of x plus h, which is right here, x plus h squared minus 5 times x plus h minus f of x, make sure you put parentheses around it, all over h. So this is your f of x plus h. You know what, let me try something. This is just FYI, I'm going to try something here. I'm going to zoom in here. Hey, easier to write. F of x over h. All right, so now you just got to do a lot of algebra, because right now if you plug in 0 for h, you're going to get 0 over 0. Just trust me. So you do a little bit of algebra, multiply the first term out, distribute the -5, distribute the negative sign here eventually. So you go ahead and try to do this, and I'll catch up in a minute. Can I see the formula one more time? Yeah, I'll write it for you down here. F prime of x is equal to limit as h goes to 0 of f of x plus h minus f of x all over h. Numerous, there's no laughing in calculus. All right, so we got the limit as h goes to 0, x plus h whole thing squared, that's x plus h times x plus h, which ends up being x squared plus 2xh plus h squared. Distribute the -5, so it gets minus 5x and minus 5h. Distribute the minus sign, you get minus x squared plus 5x. The whole thing divided by h. So we got this x squared cancels out with the x squared here. The minus 5x cancels out with the plus 5x. So we got limit as h goes to 0 of 2xh plus h squared minus 5h all over h. I can factor out an h now. Sometimes you can factor out more than an h, but just factor out an h because that's all we're going to be able to cancel with the denominator anyway. So now the h's cancel out, so we got the limit as h goes to 0 of 2x plus h minus 5. Now, if I were to plug in 0, I get 2x plus 0 minus 5. So the answer is 2x minus 5. So the derivative of x squared minus 5x is 2x minus 5. Any questions? So you guys, we have so in the little condo townhouse community we live in, well, I live in, you guys don't. I got stuck being a board member for the association. No one else wants to do it, so they say, hey, Kevin, you do it. But I'm like the worst. I don't do my job properly. So we had someone, so one of the rules is you're not supposed to drink alcohol by the pool and the jacuzzi area. So one person comes to me, this old lady comes to me, goes, Kevin, those guys, they're drinking alcohol. They're not supposed to. Go tell them. I'm like, oh, shit. So I go, they have these red cups in their hand. I go, well, you know, I can't really accuse them of anything. They could just be drinking soda. I mean, I can't just accuse them. So I just try to get out of everything. It's really bad. I'm like, hey, you know, if you want to be a board member, go ahead. But no, I don't have time. Well, like I do. I mean, this is pre-COVID times, okay? I didn't. I was like literally at Fullerton College, 1 hour, the next hour at Cal State Fullerton. I didn't have time to do this crap. Anyway, you have me doing it. So as long as they're forcing me to do it, you know, they're going to get a shitty job like that. You're drinking alcohol by the pool. I mean, I can't tell it's alcohol. It's in a red cup. It could be, you know, Gatorade. Okay, moving on. Okay, I don't know where I was thinking of that. Just heard people talking. They looked like they were drinking. All right, moving on. Let me do this next one. F of x equals 4x plus 7. So I'm going to do this one. Well, it's actually pretty easy. So f of x plus h is 4 times x plus h, then plus 7. Now, there is a reason I want to do this one because you're going to get a answer that's a little different looking than the other ones. The derivative is limit as h goes to 0 of 4 times x plus h plus 7 minus 4x plus 7 all over h. So we're finding the derivative of f of x equals 4x plus 7. So this is your f of x plus h minus your f of x all over h. So you guys finish simplifying this one. All right, so we got limit as h goes to 0. If I distribute the 4 here, I get 4x plus 4h plus 7. Distribute the minus sign, 4x minus 7 all over h. So the 4x and the minus 4x cancels out, 7 and the negative 7 cancels out. So we got limit as h goes to 0 of 4h over h. So now the h's cancel out. So you got limit as h goes to 0 of 4. What's the answer to that? 4. So notice here, we took the derivative and we just got a number 4, whereas the other problems that we got a formula like 2x minus 5 or 2x. So the reason for that is, remember I told you the derivative is the instantaneous rate of change. It's the slope, gives you the slope of the tangent line. So if you remember how 4x plus 7 looks like from algebra class, it's just a straight line with a slope of 4. So does it really matter what x value we're talking about here? Because the slope of the tangent line is going to be 4 no matter where you're at on this line. It's going to be 4 no matter where you're at. So so it doesn't depend on x, it's 4. So that's why this derivative is 4. So I can see how the derivative is related to the slope of the tangent line. Now, I do got to do another question here before we go a break. All right, find the equation of the line tangent to f of x equals x squared minus 5x at the point 1, negative 2. Hold on, not 1, negative 2, 1, negative 4. That 1, negative 2 is not even a point on the line. So here's how you do this. So this is the question, and I'll do the answer in blue. So first thing you got to do is take the derivative so you can see what the slope of the tangent line is. So this is an example that we did. So the majority of the work would be taking the derivative. So after a while, you'll get the derivative to be 2x minus 5. And we did that up here. That's what we did here, 2x minus 5. So we get 2x minus 5 is the derivative. Now you're going to plug in the x value, which is x is 1. Because if you plug in x into the derivative, that will tell you the slope of the tangent line. So we plug in 1, because that's the x value of the point, and we get 2 minus 5, which is negative 3. So therefore, that is the slope of the tangent line. And you know that y equals mx plus b. I like to use the slope-intercept form. So, and m is negative 3, so y equals negative 3x plus b. Now I just got to figure out b, then I got the whole equation of the tangent line. Well, I know it goes through the point 1, negative 4, so we'll plug that in. So negative 4 equals negative 3 plus b. Add 3 to both sides, b equals negative 1. So once you got that, then the answer is y equals negative 3x minus 1. And there it is. That's the equation of the line tangent to the function f of x equals x squared minus 5x up here at the point 1, negative 4. Some people use point slope form, but I like to use slope intercept form. So recap the problem. So you have your f of x equals x squared minus 5x. You take the derivative, which will take some time because you're practicing the limit definition of derivative, and you get that. Once you get the derivative, to get the slope of the tangent line, you plug in this x value 1, and you get the slope at x equals 1. Slope of the line tangent at negative. So its slope is -3. So then you plug it in for m here, -3. Then the rest is just like algebra 1. Does that make sense?
Professor,
Yeah.
why is -3 the slope? Isn't it just the y value, or when f of f prime is 1?
Yeah. So 2 minus 5 is -3.
So isn't that just the y value of the point 1 comma -3? Why is it the slope?
No, -4 is the y value, because 1, when you plug it into the original function, 1 minus 5 gets you -4. But when you plug in 1 into the derivative, that's the slope of the tangent line.
Oh, so it's not the y value of the derivative function when you put in 1?
Well, you don't call it the y value. It's the y value is -4. The y value is right here, -4. You see where I'm pointing at the cursor? That's the y value. The derivative, the slope is -3, because 2 minus 5 is -3.
All right. I got it.
I don't know what you're keeps trying to ask, the y value of the derivative. That makes no sense. You mean the output when you plug in 1 into the derivative?
Yeah.
Yeah, that's what it is. Look, 2 minus 5 is -3.
And I don't know why this is confusing for me. I feel dumb for it. I kind of feel dumb about this. But...
No, it's okay to ask questions, but I don't understand your question. Because you keep saying the y value. I think you mean the output, but the output, yeah, the output at x equals 1 is 2 times 1, which is 2 minus 5 is -3.
So the output of the derivative function is always going to be the slope?
At that particular x value.
Okay. I didn't think I get it. Thanks, Professor.
Will we have a line once we finish this to double check this answer, or is it just the question itself that we're given? We're not given an actual graph.
Well, you'd have to know how to graph this parabola. It's not centered at, it's not, the vertex is not at 0, 0.
So we're just
But-
given a question. We're never
yeah.
given the actual graph.
Yeah, well, no, we're not focusing on that right now. Right now, this section, we're focusing on this procedure right here. This is what you're practicing right now in this section. We're gonna do more equation of tangent lines and equations of other types of lines in a later section. But really, you wanna focus on this process right here, right now.
Okay. Is there any way once we're finished with this problem to check that your answer is correct? Or is it just like, if you did it wrong, you did it wrong? You
Give
wouldn't
me
know.
next week. It's the derivative. I'll show you really quickly how you can get the derivative next week.
Oh, okay. All right.
All right. So we're gonna take a break. We'll start back at 4:27.